Good afternoon to all of you all. In this video, we wish to see what is the energy density, power and intensity of a harmonic wave in a stretched string. Consider a string which is fixed at one end and the other end is free. You can oscillate this end and the string is assumed to be a homogeneous medium. That is, the elastic properties are same throughout and the inertia properties are also same throughout. If that is the case, then the wave which travels along the string will move at a constant velocity v given by root of T by mu, where T is the tension in the string and mu is the mass per unit length. Yes, mu is the mass per unit length. The area of cross section is A. A is the area of cross section of the string and rho is the density of the string. Rho is the density of the string. We can easily see how all these things are related. Mu is mass divided by the length. The mass can be written as volume into the density. The volume would be the area into the length, that would be the volume, into the density by L. So L cancels and you have mu is equal to A rho. Okay. Now supposing this end of the string executes simple harmonic motion. Yes, given by y is equal to, let's say, A sine omega t plus delta. So this is the source. This is the source from which you are giving energy. That energy moves along the string in the form of a wave. And because it is executing a simple harmonic motion, the wave will also be a sinusoidal form. It will be a harmonic wave. So you will have a harmonic wave traveling along the string. Now, what you must see here is that this source, if you consider a small element of a string there, a small element of a string having mass m, the small element having a mass m, the energy of the source would be, the energy of the source particle I will call it, would be half Ka squared. K would be m omega squared, A squared. That is the energy of the source particle. Now what we must note is that every particle in the medium copies the source. So all particles along the string are going to execute SHM with the same amplitude A and the angular frequency omega. So omega and A is going to be the same for all the particles, except that there will be a phase lag. They will be lagging the phase because the wave takes a finite time to reach faraway parts of the medium. It does not, the disturbance at the source does not reach instantaneously to any part of the medium. It takes a finite time because there is a finite velocity v given by this. Now, how do we define energy density? Supposing this is the wave traveling through the string and supposing I consider a certain volume here, certain volume of the string. This is certain volume of the string. Now, every element in this volume will be executing SHM. So each element will be associated with some total energy and we can add up all those energy. That energy per unit volume is the energy density. So the total energy would be, supposing there are n elements here. We divide this length of the string into n elements. So the total energy would be n into half m omega squared A squared. That would be the total energy. Let's say the volume is V. So this would be the energy density U in joule per meter cube. Now N into M is the mass of the string within this volume, and the mass of the string divided by the volume will give you the density. So the energy density expression would be half rho omega squared A squared. That is the expression for the energy density. Now the next thing we would like to see is the power. The energy is reaching every part of the string down the line. So supposing you consider the area of the string A, there is some energy passing through this area, and we would like to know at what rate the energy is passing through this area. That is known as the power. The power is the amount of energy passing through a given area in unit time. So how do we do that? For doing that, the wave travels at a speed v. So in a time t, the wave would have traveled a distance v into t. So the amount of energy that has crossed this area in this time t, we can find out by considering the volume of this string, which is nothing but a into v into t, and whatever energy is there in that volume, that energy has crossed the area in a time t. All that energy has crossed this A in a time t. So that volume into the energy density by the time will give us the power. Yeah? So T would cancel. You have A into V. U is nothing but half rho omega squared A squared. A into rho is mu. So we can write this as half mu omega squared A squared into V. That is the power of the wave traveling through the stretch string. Then we shall talk about the intensity. The intensity is the amount of energy crossing unit area held normal to the direction of propagation in unit time. Yes. So the intensity is nothing but power divided by the area. It is power divided by the area. So the power is half mu omega squared A squared into V by the area. Mu we know is A into rho. So A would cancel, and you will have the intensity as half rho omega squared A squared into V. Half rho will be half rho omega squared A squared into V. Half rho omega squared A squared is nothing but the energy density. So the intensity is nothing but the energy density U into the speed of the wave. Thank you.